Hi guys, let's go ahead and talk about section B5. This is the third section that we've covered. This one covers rational expressions. You should be looking at your notes as we go through this together. You'll see the beginning of the note states that a rational expression is a ratio of two polynomials. We've talked about polynomials. We know that polynomials are it's like a collection of terms, and each term might have a variable, might have an exponent. So polynomials can look like just maybe x minus 3. A polynomial, this one up here on the top, would be a trinomial. That's x squared plus 2xy plus y squared. Alright, so all of these are polynomials, and the rational expression just indicates that they are, you've got a fraction that's comprised of polynomials. So these are what rational expressions look like. These are just examples of what we'll be working with. We start with the definition of domain. This is very important. So let's read this together. The domain of a rational expression is the set of all real numbers that can be used in place of the variable. In other words, that means the domain would be any number, the domain would include any number that you can put in for x or for y and get a legitimate answer back. So you can think of it as inputs if you want to. For example, in my very first example here, I'm looking for values that I could put in for x. So, I could put in a 1 and I'd get an answer back, etc. Let's look at example 1 part A. We want to find the domain here. Alright, so we have to be careful that we're thinking about possible restrictions on our x. In this piece, or in this example, there is a restriction on our denominator. It is possible to put a number in for x that will give us what we would consider an undefined answer. You might know what that is, or maybe you don't. I don't know. But the key here is to think about what value. Basically, if you look at your notes, you'll see that I've got a reminder that we know from arithmetic that we cannot divide by 0. So that just simply means that let's just talk about that for a moment. Just going all the way back to when you first learned division, a long time ago. If you were asked to do something like 7 divide by 0, let's just see what would happen if we tried to do that. So if you were to set up a division problem, you would do 7 divided by 0. This is asking us to find a number that we can multiply by 0 that would give us this number on the inside. And hopefully you see that that is a problem. If you try to multiply any number by 0, it will always equal 0. So that's why we have this rule that we can never divide by 0. That's a very important rule to remember. So we're going to think about this up here. We have to be careful that we do not put a number in for x that would give us a denominator of 0, because that's the same thing as dividing by 0. So what number would I not want to put in for my x? In other words, what value of x would we think of as a restriction? If I put in -3 for x, then that would give me a denominator of 0. So I can say that my domain is every real number except x cannot equal 0. So we'll say our domain is all real numbers except all real numbers except -3. Alright. Or it could also be written as this symbol means all real numbers, comma, x cannot equal -3. You might also at some point need to use set notation to express your answer. If you did, you would just say the set of all elements x such that x does not equal -3. It just depends on which way you're asked to do it in my math lab. As far as I'm concerned, this answer is perfectly acceptable. You're telling me that it's all real numbers except x cannot equal -3, and that's good. What about part B? It's the same concept here. We've got to be careful that we're essentially looking for any value of x that would give us 0 in our denominator. So because this denominator is a little different from the last one, because this one could not be factored, but x squared minus 9 can be factored. So let's go ahead and factor that first. So we've got x plus 4 over, and then we know that's a difference of squares. It factors as x plus 3 times x minus 3. Once it's factored, it's a lot easier to see what values of x would give you an undefined answer. We can see that if we put in negative 3 here for x, or if we put in a positive 3 here, either one of those would give us a 0 in our denominator. So we can say that our domain is all real numbers, but x cannot equal 3 or negative 3. All real numbers, x cannot equal 3 or negative 3 is our domain. So we're ready to talk about example 2. We start on our second page of notes discussing the basic principle of rational numbers. That simply states that if you've got basically any fraction, and you've got the numerator and the denominator both factored, so you've got 2 factors in the top and maybe 1 or 2 factors in the denominator. If they share a common factor, then we can reduce and just basically cross out that common factor and replace it with 1. So let's look at part A. And it should be this, excuse me. So part A, we're asked to reduce to lowest terms x times x plus 1 divided by x times x minus 3. Okay, so you can see that we've got a common factor of x on the top and in the bottom because it's being multiplied to all this other stuff over here. So because these are being multiplied, we get to reduce. And anytime you've got any value divided by itself, it always gives you 1 because anything goes into itself one time. So you can cross these out and just replace it with 1. And then our answer will be the x plus 1 over x minus 3. For part B, again, you're looking for a common factor that both the numerator and the denominator share. This time they share a common factor of x minus 5. So we can cross out these 2 factors and just replace it with 1. And that just leaves us with x plus 2 over x plus 4. How is part C different from the ones that we've just done? Part C has a little bit more work. We have to see if anything can be, we have to go back and look at the rule again. Notice that it states that you have to have factors being multiplied to each other before you can reduce. So this is a very common mistake that people make all the time. You cannot reduce anything here because we do not have factors. These are all separated by pluses. That makes them terms. And it also makes sense if you think about when you reduce, like we did back here, we essentially divided something by itself, and it makes sense that division would undo multiplication. So they have to originally be multiplied together before you can undo the process with division. So let's see if we can get this numerator and this denominator to factor for us. All right, in the numerator, 2x plus 4, that has a common factor of 2, so we can pull that out. That leaves x plus 2. Our denominator is a trinomial. Alright, so you're going to think about, if you want to think of a times c, your a is 1, your c is 6. So you need factors of 6 that you could add or subtract to give you your middle term here, 5. It might not be obvious at first glance, but also pay attention to your signs because everything is addition over here. You need to find a pair of factors that have the same sign, and then when you add them both with the same sign, they would give you your 5. So we would need to subtract the 1 and the 6 to get a 5, so that's not going to work. We can go with the 2 and the 3. And if you could rewrite it using the grouping you could rewrite it in the factor using the grouping method. But what I would do here, just notice that if your a is 1, the numbers that you get here are the same numbers that will go into the parentheses after you go through the factor by grouping process. Okay, so again, because a is 1, I can just go ahead and say that my factored version is x plus 2 times x plus 3. Okay. Again, if you struggle with factoring, please know that you are not alone. we should have ample time in class because we're doing these video lectures that I can answer any questions that you have. So please don't hesitate to ask me if you're not seeing. As you're going through your notes, just mark it so that you don't forget. And then when you come to class, when I get an opportunity, show it to me, and I'll be happy to look at it with you. All right. So we see now we've got a common factor of x plus 2 over x plus 2. So these can be reduced, and we are left with 2 over x plus 3. Alright, you probably noticed that I'm at home in this video, so I'm going to have to erase the board before I can finish this problem because I've got a smaller whiteboard here. Okay, so for part D, we're asked to reduce the lowest term, so we've got b minus a over a cubed minus b cubed. The a cubed minus b cubed should look very familiar to you. That is a difference of cubes. It also happens to be the exact same letters that are used in the formula, so this should be really easy to factor. If you may not remember the formula off the top of your head, but make sure you do know it before your first test. But our difference of cubes formula a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Okay, so that's what we're going to be substituting in that second line. So in the top we've got b minus a, and in the denominator this factors as a minus b, a squared plus ab plus b squared. Alright. What about that trinomial? Do I have to try to get that factor? No, I don't. I do not have to worry about factoring this because this is the result of the factoring formula that was given to me. If it factored further, the formula would compensate. It would tell us if we needed to go any further with it. So I don't have to worry about factoring this trinomial. Looking at this, what do you notice? We've got b minus a over a minus b. This is that situation that we discussed before, where you've got the same terms but the signs are opposite. So do you remember how we can fix that? This is when we can factor a negative 1 out of one of these factors. When I say factor, I'm looking at that entire numerator as one factor, and I'm trying to see if I can get it to reduce with the a minus b factor in the denominator. So if you recall, we can factor negative 1 out. All it does is change the signs, and it makes the two factors identical. So we can go ahead and cross this out and just replace it with a negative 1. Alright, if you don't know why, ask me during class and I'll be happy to talk about it more with you. But we also discussed it extensively in it's either the first video or the second video, I'm not sure, so you should have seen it somewhere. Alright, but anyway, we can cross out these two factors and just replace it with negative 1. So our answer is negative 1 over a squared plus ab plus b squared, and again we don't have to try to factor that denominator because it came from our factoring formula. So that's our answer for part D. So we're going to talk about multiplying rational expressions. Before we do that, let's just take a moment to review some basic fraction operations that you may be, sometimes people are a little rusty on these. When you multiply rational expressions, you're following the same rules that you followed when you multiplied any fractions. The rules for multiplying fractions are really simple. They're the easiest ones that we work with. When you multiply fractions, you just multiply straight across the top and straight across the bottom, and that's all you have to do. Sometimes you might need to reduce, but other times you may not have to. So looking at my first one, 2/3 times 5/7. If you look at the 3 and the 5, look crosswise. Do 3 and 5 share a common factor? They don't. 2 and 7, they do not share a common factor. So we can just multiply straight across the top and get 10 straight across the bottom. 3 times 7 is 21. 10 over 21, they do not share any common factors, so we don't have to reduce that. And we are done. In the second example, 3/5 times 10/9, this time I can reduce first. So that you could reduce at the end, but it's much more helpful to reduce before you multiply. And in the problems that we're going to be doing, you're definitely going to need to reduce before you multiply. So just looking crossways here, we have a common factor of 3. So that becomes a 1. 9 becomes a 3. And then 5 and 10 share a factor of 5. So 5 goes into 10 twice, and 5 goes into 5 once. So we're just left multiplying 1 times 2 on the top, 1 times 3 on the bottom. So our answer is 2/3. So we're going to follow those same rules for multiplying our rational expressions. So example 3, part A, we need to multiply 2a minus 2b over 6 times 9a over a squared minus b squared. Before we can start trying to, so let's take this one step at a time. We're multiplying fractions. We know that we multiply straight across the top, straight across the bottom. We also know that we need to reduce anything first if we possibly can. So in order to reduce, well, you could go this way. You can see the 6 and the 9, they do have a common factor of 3. So you could go ahead and reduce these two coefficients. Looking at the 2a minus 2b and the a squared minus b squared, we need to decide if that can be factored as well. Or excuse me, we need to decide if that can be reduced. In order to decide if we can reduce it, we need to factor it. So you'll get lots of practice with factoring when you're going through these problems in this section. So in this one, the first numerator, you can see we have a common factor of 2. So 2 times a minus b over 6. And then here we have the difference of squares. That's a plus b times a minus b. Okay, before we try to multiply, let's see if we have any common factors crossways. So a minus b and a minus b, we can reduce those. 6 and 9 we can reduce by a factor of 3. 3 goes into 6 twice. 3 goes into 9 3 times. And you'll also notice that we've got 2 divided by 2 now, which is just 1. So that can be reduced as well. So what are we left with? Our numerator, we have 3a. In our denominator, we have a plus b. Do you think I could do anything else to this? Alright, sometimes people want to cross out the a's, but remember we cannot cross these a's out because this a is a term, it's not a factor. You can only reduce the factors. So we're going to have to leave it just like it is. 3a over a plus b is our answer. For part B, we've got a very similar type of problem. We just have to do a little bit more factoring here. My numerator, x minus 1, that will not factor. Because it won't factor, I'm just going to think of the entire numerator as a factor. So if you want to put this in parentheses, that's okay. That just kind of helps you look at it as a factor. And then maybe in the denominator, after we've factored these trinomials, maybe we'll have an x minus 1 show up. In this denominator, x squared plus 4x plus 4, you think that one, see if you can factor that. As a matter of fact, pause the video here, go ahead and factor these and see if you can find anything that you can reduce. Okay, so let's see how you did. X squared plus 4x plus 4 factors as x plus 2 times x plus 2. Or you could say x plus 2 quantity squared, but there's really no reason to write it as a square at this point. Over here we've got x plus 2 in the top. That does not factor, so you can think of this as a factor itself. And my denominator, I need opposite signs, and I need my 3 to be positive and my 1 negative. So I didn't go through all the steps for the factor by grouping method on that, but hopefully you're able to do that on your own at this point. If you're not, I can show you some tricks, so just let me know. What can we reduce here? Alright, we've got the x minus 1s. They can cancel out. Alright, I'm going to ask you a question, and it may seem like a silly question, but sometimes people don't know. If you've got two factors beside each other, can you reduce those? The answer is no. These are being multiplied together. You only get to reduce if you're dividing something by itself. So you can reduce this x plus 2 with this x plus 2. Alright, I don't see anything else that can be reduced. My numerator is left with just a 1. And my denominator has x plus 2 times x plus 3 left. Okay, so 1 over x plus 2 times x plus 3 is my answer. Next, we want to talk about dividing rational expressions. When we divide, just like you did in basic arithmetic many years ago, when you divide fractions, the rule is that, let's say you've got 7/3 divided by 1/2. You keep the first fraction just like it is, and then when you divide, you're going to multiply by the reciprocal of your second fraction. What does reciprocal mean? That just means that you flip it upside down. So 7/3 divided by 1/2 becomes 7/3 times 2 over 1. Once you have it as a multiplication problem, it's exactly the same steps that you did for the multiplication. If you can reduce something at this point, you want to try to do that. This does not have anything that can be reduced, so I'm just going to multiply straight across the top and straight across the bottom. I get 14 over 3. Now, you might want to go further with that because 14 is a lot larger than 3, but they don't share any common factors. So this technically is simplified. It could be written as a mixed number, but in algebra, we most of the time we prefer to just leave them as improper fractions. So that's it. That's as far as I would take that. Let's look at example 4. In part A, we want to divide 9 over 2x with 3 over x. So we're going to do the same step. We're going to keep the first fraction like it is, and then we're going to multiply by the reciprocal of the second fraction. And now I need to see if I can find anything that can be reduced. Looking this way, the 9 and the 3 have a common factor of 3, so 3 goes into 3 once, 3 goes into 9 3 times. And then this way, you see we've got a common factor of x, so we can cross those out as well. What does that leave me with? My numerator has a 3, denominator has a 2, and a 1, so my answer is 3/2. You might notice that I'm putting an arrow here instead of an equal sign. I do that because I like to go vertically when I'm working through these problems. I don't like to just slap equal signs beside things in algebra because you have to be careful to distinguish between an expression and an equation. There's a huge difference in how they're handled. So it can get very confusing if you start putting equal signs next to things. So I like to go vertically with it, and if I run out of space, I'll just put an arrow for my next step. Example 4b, you'll notice I left you an entire page to work on this one. I don't think it's going to take up that much space though. I don't think it's that bad. What do we need to do first here? You can start by factoring, but personally, my opinion is that anytime I'm dividing fractions, my first step, I want to go ahead and change it to multiplication and take the reciprocal, so I'm done even thinking about that part, and I don't have to worry about forgetting to do it later. It's a super easy step. You might just do it when you copy the problem down. So let's just write it as 4 minus x squared over 6 times 2 over x minus 2. And now what can I do? Can anything be factored? 4 minus x squared needs to be factored. That's a difference of squares. Do you know how that factors? Why don't you pause the video, go ahead and see what you can do with this problem, and then we'll compare. Okay, so let's see if we agree. 4 minus x squared, that's difference of squares. It factors as 2 minus x times 2 plus x. X minus 2 does not factor, so it's just going to be treated as a big factor. So again, we've got the situation where we've got two factors that are almost the same, but they have opposite signs. So we know that we can just reduce these, but replace with a -1, because that -1 would change the signs in one of them. So that leaves me with -1 times 2 plus x times 2 over, and the 2 and the 6 can be reduced, so let's do that. 2 goes into itself once, 2 goes into its 6 3 times. So our answer, so no, it didn't take up a whole page. We're left with the -1, and then in parentheses we've got the 2 plus x, which I'm going to write as x plus 2 because I like that better. And in the denominator, the only thing left is my 3. Alright, there is more than one correct way to write this answer though. The answer that we just got is correct. If it's a multiple choice question on a test, you've got to make sure that you can identify the correct choice. So you could put the negative in front of the fraction, and you could write it as negative and then x plus 2 over 3. You could write it that way. You could also distribute the negative through the numerator, and you could say it's negative x minus 2 all over 3. Okay, so all three of these are correct answers. I probably would not leave the 1 there though. I'd probably just put a negative in the front. So that answer is fine. Smiley face. This answer is good. And this answer is good. All three of these are good answers. Okay. So let's look at examples of addition and subtraction of rational expressions. These problems tend to get rather large before you finish them. We're definitely going to need to start by finding our common denominator here. We've got x over x minus 1 plus 2x plus 3 over x squared minus 1. How do I find a common denominator with rational expressions? You can think of this as there's a rule that states that, or basically I guess the definition of least common denominator is that you need to find the product of each factor raised to its highest power. What does that mean? Well, let's factor all of these denominators as far as we possibly can, and then from the factors that we get, we need to use each of those, and if we have anything that's being raised to the second power or the third power, we would need to include that exponent. So it's a lot easier to see it than it is to understand it from my explanation, so let's take a look. My first one, this denominator cannot be factored, so it's going to stay just like it is, and the x minus 1 will be thought, we'll think of the x minus 1 as a factor. And in terms of finding our common denominator, we're really not interested in factoring the numerator. We'll want to see what happens when we factor our denominators. Over here, if we factor this, it's going to be x plus 1 times x minus 1. Excuse me. Alright, so now we can see that the factors in our denominator include x minus 1, x plus 1, and then x minus 1 shows up a second time. Well, we just need to make sure that we include every factor that was given to us here. So my LCD is x minus 1 times x plus 1. This is redundant. I don't need another one. So my LCD is x minus 1 times x plus 1. So this is how I need to, my equivalent fraction now is going to come from using that LCD. And I'm going to kind of combine my steps just a little bit. When I was working with just arithmetic, I kept two separate fractions. But because there's so much to write in these problems, I'm going to go ahead and combine the fraction at this point, and then we'll have to simplify it from there. So I'll go ahead and put my LCD in my denominator. So the x minus 1 times x plus 1. My numerator up here, I've got the x already. What do I need to multiply this denominator by to give me this LCD? This denominator is missing which factor? It needs the x plus 1. So I'm going to multiply the numerator by that missing factor x plus 1. So it's going to go here. Bring down my plus. On this side, this denominator has everything. There's nothing missing from this one. So I don't have to do anything to the numerator. I'm just going to bring it down just like it is. Now we're going to need to combine, we're going to need to distribute and combine like terms in the numerator. Alright, so why don't you pause the video, work on distributing and combining like terms in the numerator, and then think about whether or not it might reduce from there. And I'm going to erase the board and then we can finish it together. So let's see how you did. When you distribute in the top, you're going to say, you're going to have x squared plus x, and then over here there's nothing to distribute. You're just going to have 2x plus 3. The denominator I'm going to leave just like it is. It's already factored. My numerator, I can combine x and 2x. So I've got x squared plus 3x plus 3 over x minus 1 times x plus 1. You always need to think about possibly being able to reduce your answer at the end. Look at the trinomial x squared plus 3x plus 3. Is there any way that we might be able to get that to factor? You've got your a is 1, your c is 3, so you need factors of 3. Well, that would just be 1 and 3. Alright, so if you think about possible factors of 3 that you could use to factor your numerator, you would need a pair of numbers that would add together to give you this middle number, 3, and those numbers are not going to do it. So that numerator does not factor. That tells me that everything is already completely reduced, so this is my answer. X squared plus 3x plus 3 all over x minus 1 times x plus 1. Example 5, part B. This time we're subtracting. We still need to factor our denominators and find the LCD. The key difference that you have to be careful of when you're subtracting rational expressions is that you're going to have to distribute, at some point in the problem, you're going to be distributing a negative through multiple things over here. Sometimes those things have to be distributed, and you've got to pay close attention to that negative and make sure that it ends up where it needs to be. That's going to be the trickiest part about these. Alright, so let's see if we can get these to factor. Alright, that's going to factor as x plus 3 times x plus 3. And over here, we'll have, these are all additions, so you're going to want to use 2 and 3. Okay. There is one significant piece of this that we've got to pay close attention to. We've got x plus 3 times x plus 3. You can think of that as x plus 3 quantity squared. If you remember when I told you about the LCD and how to find it, I said that you would need to include any powers of a factor that you might encounter. So the x plus 3 is just, is x plus 3 squared. Alright, so that means our LCD will have to include x plus 3 quantity squared. What else needs to go on my LCD? What other factors do I have? This denominator has the x plus 2, and then it has the x plus 3 again. So we need to include the x plus 2. Okay. That x plus 3 is okay. It's going to stay right where it is. We do not need to put another x plus 3 in our LCD, because we have x plus 3 squared already in here, and it includes that factor. So we just need the x plus 3 squared that we had here, and we need the x plus 2. And you're going to have to excuse me while I go tend to my baby. He just woke up. But hopefully he's down for a little bit longer. So we had found our LCD to be x plus 3 quantity squared times this x plus 2. So we can now rewrite this entire problem as a single fraction with the LCD, and we'll work on making the numerator and turning it into our equivalent fraction that we need. Okay, so we got a big fraction. Here's our LCD. Alright, the first fraction, what is it missing from the LCD? Well, the LCD has an x plus 2 factor, so I need to put the x plus 2 factor into this numerator. Again, if there's anything that you are not understanding, please, please, please let me know in class. Yes, we have a pretty large class. There will be a lot of people in there, but I'll be making my way around trying to talk to everybody. So just let me know if there's anything that you're struggling with. Over here, what are we missing in this denominator? There should be another x plus 3 factor, because we should have x plus 3 squared. So we need to multiply the numerator and the denominator by the extra x plus 3. So I need to have parentheses. When I put this all together, this binomial absolutely must go into parentheses so that we know how to distribute our negative here, because it's got to be distributed to both terms. And then we also need to multiply this by the x plus 3 factor that was missing from the denominator. Okay. So let's start distributing that numerator. We've got x squared plus 2x. All right, I'm going to go ahead and write my LCD in so we don't forget about it. Okay. All right, so we've got x squared plus 2x, and then this is where I told you that you have to be super careful with distributing this negative. My recommendation is to just leave it as subtraction now, and I'm going to put like a square bracket and go ahead and FOIL these two factors inside the square brackets, and then I'll come to another step and then distribute that negative. Alright, so we'll FOIL that. That'll be x squared plus 3x minus 3x. Those middle terms are going to cancel out. Notice these are conjugates. And then negative 3 times 3 is minus 9. Alright, and now I can distribute my negative through here. So I'm obviously out of space. Why don't you go ahead and pause the video and see how far you can get from here while I erase, and then we'll finish it together. This is where we left off. Let's go ahead and distribute the negative into the brackets now. So we got x squared plus 2x minus x squared plus 9. And I know it's redundant to have to keep copying this LCD, but you don't want to forget about it at the very end of the problem. So you've got to be careful that you keep up with it. Don't just, it's tempting to only work on the top line, but if you forget that denominator, that's a lot of points that you're losing, so you need to keep it. Going back up here, x squared minus x squared, those cancel out. I'm left with the 2x plus 9. Alright, do you think you could do anything else to this? Not really. There's nothing that, this numerator does not factor. There's nothing that can come out of these two terms, and it definitely does not reduce with anything in the denominator. So this is as far as we can take it. This is our answer. 2x plus 9 over x plus 3 quantity squared times x plus 2. Well, apparently that was the last problem of this section. I didn't realize we were finished with it already. Make sure that you don't forget to do the quiz in my math lab before you come to class. Come in ready to practice and ask questions, and we'll be working on these together. All right, I'll see you in class.